Hello all. Today we will be discussing about how we can create a machine learning program that is a heart attack risk predictor with the help of auto machine learning techniques. Here we will be using Eval ML as a automated machine learning technique. So let us dive into our main topic. Let us understand a bit about a real world topic, that is the heart attack. We all are familiar about how lethal can a heart attack be for one's health. But what causes it? As written, a heart attack occurs when one or more of your coronary arteries becomes blocked. Over time, a buildup of fatty deposits, including cholesterol, forms substances called plaques, which can narrow the arteries. This condition, called coronary artery disease, causes most of the heart attacks. Now, we are familiar about the biomedical terms, but for to understand the problem, we need to have a more proper understanding of the problem statement. We are given a data set in which various attributes are given, which are crucial for heart disease detection. You can find this data set along with you attached to this project. Using this data, we'll try to build you different machine learning models with the primitive machine learning techniques and then eventually using AutoML techniques. Now, as I have talked about, and the main topic for our project is the AutoML techniques, let us give you a brief introduction of what AutoML techniques is. So, as written, automated machine learning is the process of automating the task of applying machine learning to the real world problems. Basically, auto machine learning is a tool or a library which does all the dirty work, that is the model building, model validation, and the other parts for you. We'll be using EvalML library for this project. As soon as we'll progress, you'll come to know more about these libraries. So let us have a brief introduction about our library EvalML. EvalML is an open source AutoML library written in Python that automates a large part of the machine learning process, and we can easily evaluate which machine learning pipeline works better for the given set of data. As written, it is very clear what the EvalML will perform. We'll understand the concepts more as we'll implement it practically. One of the important part of AutoML library is that this EvalML library takes data in the form of tables and not in data frames. The conversion is done automatically in the library. Now, what is the procedure of the project? In this project, we will first use different machine learning algorithms. Then we will understand how we can use AutoML techniques to replace all these and like EvalML for this project and to make our work simpler. After completing this project, you will be able to apply auto machine learning techniques into your project and have a deep understanding of it. So let's begin. Okay, so let's begin with our project, which is the heart attack risk predictor. As written, in this project, we will make an app which will help us to predict the risk of an heart attack a person has. We'll do the following things: data analysis, feature engineering, standardization, model building, and predictions. This will be done by using the primitive machine learning techniques. Then we'll see how we can apply these techniques into an automated machine learning model. So let us import all the different libraries like pandas, numpy, seaborn, matplotlib, which are essential for doing the data analysis part for this project. Now let's talk about loading a data set. As you are working on Google Colab, there is a different procedure for importing data set. What you can do is you have to write this command from Google Colab import drive.mount. When you'll execute it, you'll be provided a link. You have to click there. You have to select an account. You have to sign in. Then you'll have to copy this link and then you'll paste it here. Press enter. Then it will run for some time and then it will provide you authorization. As you know, it is showing mounted at content on drive. Now what this means is that all your drive data which was stored is mounted in this Google Colab drive. You can access it using this. When you'll click here, you'll see the drive. Then you'll go to my drive and you'll see like all the things which are present in my drive are present here. Now I have to read my CSV file if you want to read any file, you have to upload it in your Google Drive, then you can read it from here. Now if there is my CSV file, I'll right click here and I'll copy the path, and I'll simply write the command df is equals to pd read CSV, and I'll paste the path here, then I'll execute it. As you see, it has executed, and this is our data. This is a raw data, and this is how you import a CSV file in Google Colab. Hello all, now let us proceed with our data analysis part. It gives us a brief understanding of our data and how our features are correlated. Now understanding our data set, from this data, age and sex are pretty understandable, which stands for age of the patient and sex of the patient. 1 is if he's a male and 0 if she's a female. EXANG stands for exercise included enigma. If it's a yes, then user has to enter 1. If it's a no, the user enters 0. ZA is number of major vessels. It ranges from 0 to 3. CP stands for chest pain. It has different categories. Value 0 for typical enigma, value 1 for atypical enigma, value 2 non-enigmal pain, and value 3 stands for asymptomatic. TRT-BPS stands for resting blood pressure, which is to be entered in mmHg unit. Called CHOL stands for cholesterol in mg per dl, fetched by a BMI sensor. FBS stands for fasting blood sugar. It has two categories. If it is greater than 120 mg per dl, the user has to enter 1, and if it is less than that, the user has to enter 0. Similarly, for REST ECG stands for rest electrocardiographic results. Value 0 is for normal, value 1 having STT wave abnormality, and value 2 showing probable or definite left ventricular hypertrophy. THA-LACH stands for maximum heart rate achieved. Now target is a dependent variable, which means that if it's a 1, which means that the person is having a more chance of a heart attack, and it's a 0, which means the person is safe and have a less chance. Now let us find out the shape of our data set. As you can see, we have 303 rows and 11 columns. Now let us find out if there are any null values in our data set. As you can see, there are no null values, which is quite a good thing, because if our data set had any null values, we have to deal with them first by using different methods like mean, median, mode imputation, and different other techniques. Now, let us find out the correlation or a correlation chart between our different features, which will be stated as which will be like this. It is in a table form, which give us an idea of how our features are correlated. So 1 stands for the same feature, which means that if it's completely correlated, which is only possible for the same feature. The negative stands for the negative correlation, the positive stands for the positive correlation. Now, as soon as the number reaches the 1 or -1, it means that they are highly negatively or positively correlated depending on the data. Now let's convert this into a more graphical form, which will be easily interpretable, which can be done using a command sns.heatmap. Now, as you see, this whole data table is converted into a graphical form, which gives us the same information only graphically. These different colors and this mapping give us the information how this data is correlated. But to have an actual idea of how this data is distributed, we'll have to do different univariate and bivariate analysis. Now let's find out the distribution of our age of the patients, how age of the patients is distributed, which can be done using a simple command sns.countplot. Now, as you can see, the age group from 51 to 67 years is the maximum, which is the elderly people. And for the same, if we do for the sex, we can see that the male patients are more in number. As we can see, the 1 stands for male and 0 stands for female. The male patients are more in number. Now, for the different categories variable like the chest pain, we'll do one thing. We'll use a command which stands for dscp.valuecounts.resetindex. What this command will do, this will give me the different value counts of the different categories, and then we'll convert it into a data frame so that we can have an idea how chest pain patients are distributed. As you can see, gave me a data frame which gives us the idea that typical enigma patients are more in number than atypical enigma, and asymptomatic are less. Now, this gives us a graphical representation which can be easily understandable and easily executable by the SNS.powerplot. SNS stands for Seaborn. Seaborn is a very important library which can be used for different data analysis procedures with a single command of code. Now let's do the same for the ECG values. As you can see, the highest number is normal, and then S having STT wave abnormality, and then the second part and the third category. Now, seeing it graphically, it shows us a very pretty clear idea that these two are in abundance, and the third category, which is an abnormality, is in the least. Now, after this, we can have a multivariate analysis which will tell us how these all the features are correlated in the form of different bar plots and distribution charts. This is same as that of the DF correlation, but this is in the form of different charts. This will take some time in execution depending on your computer processing power. This library, this pair plot library is available in the Seaborn library. As you can see, the hue is a parameter which help us in distributing, or which helps us to tell us that command that how we have to distinguish the data. Hue is output, which means that it will be distributed on 1 and 0, which will be pretty understandable when we'll see the figure. Now, as you can see, it took some time, but it got executed. What I talked about, that we gave the parameter hue as output. So it gives us the distinguished parameter, which is 0 is for blue color and 1 is for orange color. As you can see on the y axis and the x axis, there are different features, and gives us different scatter plots, distribution plots, bar plots, which tells us a pretty good idea that how these features are distributed. You can execute this command and have a prior brief look on the data and how your data look. Now these all things we did are were for categorical variables. Now let's do some things or do analysis on a continuous variables. Continuous variables are variables which are present in continuous numbers. Now first let's do something for our blood pressure and maximum heart rate achieved. This is a simple distribution plot which I executed using the command sns.distplot, and I did the KD command, that is distribution estimation, for true, and I gave the color. These are the different label which I used, and as you can see both the data are normally distributed, which is a very good sign, because in order to feed a data in a model, they has to be normally distributed. Now let's do the same for the cholesterol. As you can see, the cholesterol is also normally distributed, but there are some outliers, like this is in the 550 mark and 400 mark, but there are very few to which will not affect as much. If you like, you can do the outlier approach also. Now these were all the data analysis part. In the next section, we'll see how we can standardize the data and apply that in a different machine learning models using the primitive technique. Proceed to Hello all. Now let us discuss on the part about how we will build a model. Before building a model, let us have a look at our data. As you can see, our data is various parameters, and they are either continuous or they are categorical. So before feeding our data into the machine learning algorithms, it is a very necessary step which is known as data pre-processing. Now here I'll apply a pre-processing technique called standard scaler, which will basically standardize or scale my values to a common platform so that my model will not have much variation in my data and will perform better. There are various other pre-processing techniques like one-hot encoding for the categorical variables. I have not performed these techniques here, as our main goal is to predict these things with the help of AutoML techniques, which we will do in this coming section. Now, so in order to fit my model, I have used standard scaler. So let's say import standard scaler, then we'll fit our data to it, then we'll transform it, we'll create a data frame, and then we'll see how our data is changed. As you can see, our data has been changed or scaled down to a common values ranging from -1 to around 1, which will be later fed to our models. Now we will be using following models for our predictions. First is logistic regression, decision tree, random forest, k nearest neighbor, SVM. Then we'll be using some various ensemble techniques also to see whether we can hyper tune our models or not. Now, before these, we have to split our data. We have to split our data into dependent variables and independent variables. As you can see, the x goes for our independent variables, which are different attributes, and y is our output, which is our dependent variable. Now, let us import train test split, which will split our data with a 30/70 size, that is 70% for train data and 30% for test data. We have different parameters: x train, x test, y train, y test, which will be used in a different models. Now, from proceeding to logistic regression, we will import logistic regression from sklearn library. Then I have used label encoder here because I process the target variable also. In order to fed my data, I have to bring this to a 0 1 format. That's why I'm using label encoder. In order to avoid this, you can skip the output data in the standard scaler and only scale the input data, which will be the same like this. Now we have transformed our Y train. Now let us import our model, fit our model. As you can see, our model is fitted. These are the different attributes. Now we see that here is a prediction. You see, we have predicted and we have imported for metrics like accuracy score and confusion metrics so that we can tell how good our model is performed. We'll see confusion metrics and we'll see the score. As we see, the logistic regression has performed with an 85% accuracy, which is quite good. Now, moving on to a decision tree model, we'll import the decision tree classifier, we'll fit it, and we'll see the results. As you can see, the our decision tree model has performed with an accuracy of around 71%, which is a little bit less than the logistic regression model. Now, moving on to a random forest model, we'll apply random forest classifier and we'll fit our data and we'll see how what accuracy we find. As you can see, it gave around 80% or 78% of accuracy we have from random forest model. Now we have k nearest neighbor model. In k nearest neighbor, we will use a method to find out what is our optimum number of k we have to use. For this, I'll define a function in which I'll define an error rate array and I'll iterate the I in my 1 to 40 range. This will be my k values and I'll apply all my k I'll fit my model with all the k values and then I'll try to find out which k value is the best and which is giving me the less error rate. Now then with the help of a figure we'll find out that which k value suits us the best. As you can see from the figure, the k value from 11 to 12 is a very good figure as they are showing a minimum amount of error rate rather than 26. If we use 27, this can lead us to overfitting of the model. So we'll select k is equals to 12 which is as it gives us the best and suitable error rate. Now after fitting it, we'll find out that it gives us an accuracy of about 84%, which is also quite good as compared to a logistic models and other models. Now the another model is our support vector machines. We'll apply this and we'll see what accuracy we are getting. We'll see that it gives us around 80% accuracy. As we see that these all models are performing well and around are performing quite good. Now let us convert these accuracy in the form of data frame so that we'll have a better idea which is the best. What I did here is I took all the model accuracy scores and converted it into a data frame and I used ascending is equals to false so that it will give me in the data frame in a descending order. As we see, logistic regression has the highest accuracy, which is 85%, followed by k nearest neighbor and SVM. These are some of the primitive model learning techniques which were used. Now we have different other techniques, which is ensemble techniques, which is known as Adabus classifier and other ensemble techniques, which we'll discuss. Hello. So now let's continue our model building part. The next classifier we'll be using is an AdBoost classifier. AdBoost classifier is a form of ensemble technique which is used for different model build techniques. It uses different decision trees in the form of input and gives us the best output. Now we'll import the attributes classifier from sklearn.ensemble. We'll define it, we'll fit our model, we'll predict the results, and we'll see how does it perform. As you can see, RW's classifier does not give that much efficiency as compared to the different models. This can happen because of various different parameters. We have to tune this RW's model in order to maintain its highest accuracy. Now, moving on, we'll use a grid search CV parameter to see or hypertune our best three performing models to maintain maximum output. Now, let's import grid search CV from sklearn model selection, and then we'll see what are our three best performing models. As we can see, logistic key regression, K nearest neighbor, and SPM are our best performing models. So first, applying these hyperparameter tuning in logistic regression. These are the different parameters of a uh, logistic regression in which solver, penalty, and C. These are different attributes. We have defined them in a parameter grid, and then we'll give this parameter to our grid search CV model, and then we'll fit the model and find out what are our best parameters. As you can see, the best parameters are C is 0.01, penalty L2, and solver is lib linear. We'll apply these parameters to a model and see how does this our model performs. We'll do the same things which we've done before, and as we see, our model performed an accuracy of 81%. Now, moving on with the KNN classifier, we'll do the same things. We'll define the parameters, we'll feed it to the grid search CV model, and then we'll see that how does the model perform. First, finding out the best parameters, it will take some time as it iterates about a many number of iterations and gives us the best parameters. As you see, the best parameters are the metric is Manhattan distance, number of neighbors is 11. This is the same in neighbors as we predicted during a function graph. Weight is the distance. Now let's apply these models in the k nearest neighbor. As we see, it gave us an accuracy of 82.5%, which is a slight increase from the previous one. Now using the SVM model, we'll see find out the best parameters, what fits them, and as we see, we get the best parameters is 0.1 and gamma scale kernel is sigma. After applying these to our SVC model, we see that it gives us a score of about 81%. Now, after comparing all these models and after hypertuning, we can say that logistic regression with no hypertuning gives us the best accuracy of about 85%. So we'll be using that as our final model to predict the results. Now, in order to a final conclusion of our primitive machine learning techniques, let's build a proper confusion matrix for our model. What we'll do here is, as you can all are aware about the confusion matrix, it gives us about the true positive and true negative of the model. What I did here is I used a method called alt.plot subplots, and then I used various ticks and X labels to make my confusion matrix, and then I named my X label, Y label, and title, and then here is my confusion matrix, and I also printed my accuracy of the model, which shows the accuracy of our model is 85.7%. So we used logistic regression model as a best performing model, but these all things are done with the help of primitive machine learning techniques that a data scientists do. In the next section, we'll see that how can we skip all these hustle and perform these with a single line of code with the help of auto machine learning techniques. We'll be using we will be using Eval ML in this techniques, which will be discussed in the next section of the video. Hello all, in this section we'll be discussing about the different auto machine learning techniques which we can use instead of the machine learning techniques which we have used in the previous sections. We'll be using EvalML for this project. EvalML is an open source auto machine learning library written in Python that automates a large part of the machine learning process, and we can easily evaluate which machine learning pipeline works better for the given set of data. You just have to provide a certain type of data, and EvalML will give you the predicted output by comparing all the different parameters and hyper tuning parameters and models in it. First, you have to install EvalML. You can do it by either command prompt, or you can directly install it in your collab environment by writing exclamation pip install EvalML. I have already done it, It will take around 5 minutes to get installed and it will download all the libraries. Then we'll read a dataset previously from pd.readcsv given the copied path. Then we'll see a dataset. It is the same as before. We'll do nothing. We'll just split the data in a dependent variable and independent variable. As we see, well, this is our dependent variable, the target variable, and these are our independent variables. Now we'll import the evalml library. I've already done it. It will around take 2 to 3 minutes to get imported. Now we'll be splitting our data. What we do is we'll use a function evalml.preprocessing.split data. What this will do, this will pre-process the data like doing all the things like standards, doing standardization, one hot encoding and everything, and it will split the data in the form of train test. The proportion it uses is the 20-80%. 80% it uses for train data and 20% for test data. Now, these are the different types of parameters in evalml. Problem type, that is binary. There are different types of problem types, that is binary, multi-class, regression, time series binary, time series multi-class. Here our input is binary and which is 0 or 1. So we will be using binary. If it was more than 2, we'll be using multi-class, and if it was a number, we'll be using regression. Now, in order to search the best model, we'll use from evalml or .automl import automl search. Automl search is just like a fit parameter in which we'll give different data, and we'll do the problem type as binary, and we'll do automl.search. It will automatically search between all the different models and tune it in order to give us the best output for our model. Now, as you can see, it is using different types of data, and after that he finished the search. Its search finished after 0.15 seconds. Best pipeline is random forest classifier with imputer, and the best pipeline logos one is 0.042. Now we can also see the rankings, which will be, as you can see, there are different models, and it gave us the different scores, the CV score, the validation score, and another things. As we can see that we have a validation score, and say, oh, percent better than baseline is 97%, and a cross validation is of 0.03, which is quite less, and as a mean CV score of 42, which is the least, and this is the highest. So we can see the random forest classifier with imputer is the best model. Now we'll see which is the best pipeline. Pipeline means it will give us all the details which were used, like the imputer, which imputer was used, which classifier was used, which parameters we used, and we'll store it in a model known as best pipeline. Now, if we want to have a detailed description of this model, we can use the command automl.describe pipeline. We'll use automl ranking, and we'll select the first one, that is the random forest, by the command command dot ilog 0. It will describe us everything. We will describe the random forest computer with detail, and what are the things we use. Will be given log binary score, AUC score, Guinea and precision, F1. As you can see, different types of score are given. Now, if we want to see what score we got in the terms of objectives like AUC, F1, precision, it will be depending on your employer or the domain knowledge, the person who is having the domain knowledge, which score he has to take. We'll be taking different scores and converted into the database. As you can see, AUC score has a approximate accuracy of 91%, F1 is 86%, we have a precision of 87.5%, and recall of 84.4%. As you can see, this is far more better and far more accurate than the models we used in the machine learning. Now, if we in order suppose if our employer has said that we have to use a certain objective, like let's see, we have to use AUC score now, so we can train our model with that. What we'll do, we'll use the same AutoML search, we'll give the data, and we'll select our objective as AUC. Then we'll see the selected additional objective as F1 and precision. This will train our model based upon that, based upon the AUC ranking, and the model which is having the highest AUC score will be provided. It will take some time as it searches all the different models, and then it will be provided with the model. As you can see, it is still searching, and we can see now we get the model extra T classifier with imputer, and this gave us the highest AUC score. Now we'll see the rankings. As we can see, the extra tree classifier came up after the random forest classifier. Now we can select this. We can describe a top performing model with the help of AutoML AUC.describe pipeline, and then it will describe all the different things which were taken, AUC score, F1 precision, and the different things. We'll store this in a best pipeline. Now what we can do, we'll have a score. We'll have a score of what AUC score we have got. Now, as you can see, we have got around 91.55%, which is far more better than the previous models. Now, we have built a model in the base of with the help of AutoML technique, that is EvalML, which an accuracy of about 91%. Now, what we have to do is we'll save the model in a pickle file. What you can do this by best pipeline. Best pipeline is the thing which we stored, and best pipeline dot save model dot pickle. And in order to load a model, we can do this by final model automl dot load model dot pickle, and we can predict the results with the help of this. Now we'll predict the results. As you can see, we are getting different probabilities of the result. For the first test data, the probability of 1, that is that it is not having very not ha that the probability of 1 is around 65%. So the one output which is having the largest probability, we can consider that. For the second data, 1 is having the 97% probability, and at the list goes. So this was our topic on how we can predict a data predictor or make a model with the help of EvalML. By this technique, you learned about how you can apply different machine learning libraries and then compare it with the AutoML techniques. All the code and the link and the code in presentation and the files will be provided to you. You can take reference of this code and practice on your own in order to get the maximum.